Hello everyone. I welcome you to this class of econometric methods. Myself, Dr. Muhammad Imdadul Haq, an associate professor at the Department of Economics, Aligarh Muslim University. In our previous class, we were discussing upon how to perform Johansson cointegration in the software eViews. A quick recap of what we have done till now, and this class is basically a continuation of our previous class. We have seen how to download the software free for at least a year, and then we have seen in what are the cases in which we can apply Johansson cointegration. Only in the case where both the variables are I1 or integrated at first order. Then we have seen that we need to first test for stationarity. After testing for stationarity, when it is confirmed that both the variables are I1, then we will move forward with the process of cointegration. Next, we have seen that we will be going into the option of var, and we will select the standard var option. After selecting, we will name all the variables in the endogenous variable box over here, and then we get this output. Although this output is not much of a use for us, we will go for proc, lag structure, lag length criteria. Once we have proc, lag structure, lag length criteria, then it will lead to another dialog box which will ask you to specify the number of lags to be included. We can include 4 if it's 30 or more years or observations. Then the lag length criteria will give you an identification that which is the optimum lag, and that will be denoted by an asterisk mark. Once we know the lag structure, then we go to quick group statistics, and then we go to Johansson cointegration test. Once we go to Johansson cointegration test, this dialog box opens. Herein you will put your values of y and x. Then another dialog box comes up which asks you to select one of the 5 options given over here. We had discussed our case that normally either option 3 or option 4 are more appropriate and it happens in most of the cases. Next, once it is done, we get the results in the form of trace statistics and max statistics, and we are just concerned with this line over here which says that trace statistics indicate 1% cointegrating equations at 0.05 level, and also it is over here max statistics indicates 1 cointegrating equations at 0.05 level. So this is as such the necessary condition but not the sufficient condition. So up till here we have discussed in detail in our previous class. Now we move further. So till now what we are under the impression that there is a cointegrating relationship. Now do not close the earlier box of cointegration, because now the error correction term and the calculation of this vector error correction model, it happens in the domain of your Johansson cointegration. So if you suppose by any chance once you have done this and you click on X over here and you close this dialog box, and then you say now I will calculate this error correction model, vector error correction model, this will not happen. So you need to let that previous box open and then you go to proc. Once you have selected proc, this dialog box will open up. In this, you will have to select one of the drop down menus, that is make vector auto regression. This is nothing but var. So the moment you select this, this box will come up, and I hope that you are familiar with this box, because while estimating cointegrating relationship, the second step was this box, wherein at that time you had selected this option, standard var. You needed it for identifying the lag length criteria. But now we are not going to select that one. We are just going to select vector error correction. We are not going to select standard var, but we are going to select the second option, that is vector error correction. Once this is done, once you have selected this, now your output or your result would come. This result, this term, this is your error correction term, ECT. What does this error correction term indicate? This indicates whether there is a force or there is a phenomenon that if there is a deviation, that deviation is corrected in the process. Meaning thereby, we are just looking like, see, one of my data is like this. Another series is moving. This is my another series. Now, this series has deviated. It will not be, cointegration doesn't mean that both of these two series are going in a parallel form like a railway track. No, this is not cointegration. And this is the beauty of this process, that even if both of the series, they don't seem to go in a trend, but still there can be a long run relationship between these. And how we make a feel of it, that if this series is deviating, by after how much time this series will come back and it will again follow the earlier relationship. Or if say this series is deviating, so by after how much time it will again come back to the equilibrium position or to the same path of long run relationship. So this, if there is no such mechanism, if there is no such mechanism that the series, if normally they will deviate maybe a little or even more, but if they are not coming back, it means that both the series are diverging. It is a stochastic, their trends are stochastic, and there may not be any relationship between these two. And even if you find some significant values, it will be in a case of a spurious regression. So this error correction term, now it has three conditions. First, this error correction term should be negative. If the error correction term means, I mean to say this, refer to this, if this term is not negative, it means there is no mechanism that if one of the series diverges from the long run equilibrium part, there is no mechanism to say that that series will again come back to the equilibrium path. It should be significant. If it is not significant, it is of no use as such. And the third thing is, so it is the very first thing, and the third thing is that it should be less than 1. We will find cases, we will find in research papers, people are interpreting this error correction term, and they will say that this error correction term, it can be a value of 2, it can be a value of 1, more than 1. But understand, if it is a value of more than 1, it means what? Suppose it's an yearly data. Suppose it's an yearly data and this value is say 0.90. This means that if there is any deviation from the long run trend, 90% of it will be corrected in 1 year. Now, it is not applicable over here because this is 0.90 is having a positive sign. This can be interpreted only when if there is a negative sign over there. But just for the sake of understanding, if suppose this point was minus 0.90, suppose, then what is the implication of it? That two series were moving, one of them deviated from the equilibrium path, and whatever was the deviation was corrected to the tune of 90% in one time period, and here the time period is a year. If you have taken monthly data, then you will say that 90% of the deviation was corrected in 1 year, in 1 month. If it is say a quarterly data, then we can say 90% of the deviation was corrected in 1 quarter. But here, suppose it is an yearly data, so we say that 90% of the deviation was corrected in 1 year. And if this value is 2, by common logic, it means I deviated and I am returning more than what I have deviated. Means it is again a deviation. It is again a deviation from the equilibrium. If it is 1, what I have gone, I came back to the entire thing in 1 year. And if it is more than 1, means I came back and I went more further in another direction. So, but in most of the cases, there may be a case where this is applicable, but in generally in macroeconomic cases, in the general cases which we deal with, students of economics deal, we will have that the third condition, it should be less than 1. So now we have it should be negative. If it is not negative, it means that there is no mechanism that the series will come back. And if it is, whether it should be significant. Here significance, the last value from this we can, these statistics we can get the significance, a feel of the significance, although a rule of thumb. If this value is more than 2, so we can say fine, it is significant. But even if it is significant and even if it is, this condition is satisfied, this less than 1 condition is satisfied, but this condition of negative is not satisfied. So if this is the case, then we cannot say that there is a long run relationship between the values, because if there is a shock in the system, the series will deviate and it will not return back. That is the reason we say that the trace statistics and the max statistics, they say they are the necessary condition, but they are not the sufficient condition. Like in our case, after having this results of error correction term, we can no longer say that there is a long run co-integrating relationship between the variables x and y. Another thing which is given over here is x, means that is, we need to understand this also, because again in co-integration, although we are specifying that one is the dependent and the other is dependent when we are writing y before x, but the software will give you the result by assuming that x is the dependent variable and the others are the y is the independent variable. And that error correction term is also present over here. It is also, but it is also less than 1. That is 0.103134. It is less than 1. It is significant because this t statistics is more than 2, but it is not negative. So we cannot say that there is a co-integrating relationship in both the cases. But since we have specified, and normally we have a pre-existing knowledge that this would be the dependent variable, in all these cases we can say that we take this first series, and from this we can interpret that there is no co-integrating relationship. Now, if your work was only restricted to this, you can again go back to our previous, in the first slide, what we have seen. Not in the first slide, in the previous slides, what we have seen, you selected option 3 and 4. So what you do, now you go for select option 4 and redo the process up till here. Maybe you will get a result. If in any case you are not getting a result, you cannot prove that there is a long run relationship over here. And if suppose you have got the result, Now we do one more method so that we can get each and every variable, the results, whether which one is significant, which lag is significant, all the detailed results we will be getting. So what we do, if the results are significant, then you need to do this step. Although our results are not significant over here, it's we cannot prove that there is a long run relationship, but still I am doing this step in order to give you a feel how the remainder of the things are to be done. So you go to proc. Again, don't close the window, you just go to proc, and if you close the window again, you cannot do this step. So take care that when you do the vector error correction model, you do it in the window of Johansson cointegration. When you do the estimation of the variables, you do it in the window of the existing window of error correction model. Once you go to proc, then you go to make system. Once you ask for make system, now there are two options available: order the variable, order order it by variable or order it by lag. Normally we select order by variable. Once you have got this result, now this term, this entire term is nothing but your error correction term. After this error correction term, and the second term is it has taken a lag of the dependent variable itself. Then next time it had taken another lag of the dependent variable as an explanatory variable, and then our explanatory variable it had taken with a lag. Another term it has taken our explanatory variable with another lag. So how many terms are there? This is my first term. First term is ECT. Second term is Y with one lag. Then we have Y with two lags. Then you have X with one lag. And then you have X with two lags. So this is what, and this is our C6 is your error term. Error. So this is our model. Similarly, it is also estimating, or it is also specifying the model wherein now Y is no longer the dependent variable, rather X is the dependent variable. So again here also this is variable C7. Actually, just remember, this is variable C1, this is variable C2, this one is variable C3, this one is variable C4, and this one is variable C5. And we need to remember. And so next time what we are doing, we are taking X as the dependent variable, and in this case this is the error term. So C7 is the error correction term in the other case where X is dependent. Then C7, after that C8 is there. C8 is taking Y minus 1. C9 is taking Y minus 2. C10 is taking X minus 1, and C11 is taking X minus 2. That is X lag 2. Now, so the model of our importance, or the model which we want to estimate, is the first one. So we will look for what is the value for C1, C2, C3, C4 and C5. Now, so once you have done this, then again you go to proc. Again you go to proc and you go to estimate, and you do it in the earlier window. This is the same window where we have identified C1, C2, C3, C4, C5. We go, C1 was my error correction term, and this is Y is dependent. This is X minus 1, this is Y minus 1, this is Y minus 2, this is X minus 1, this is X minus 2. Next. Another dialog box will open, and this estimation is simply done by our ordinary least squares method. We'll be doing it by ordinary least squares method, and we select on OK. You need not do anything else. So we will be selecting this ordinary list squares and then clicking on OK. Once we have done this, this dialog box will be visible to you. Now this will give you a summary of everything what you have done till now, and as we have seen in our discussion, we needed C1, C2, C3, C4 and C5. Your C1 was nothing but your C1 is nothing but your error correction term. Now, you can, by simply using the same logic, that is 0.05, we are doing at 5% level of significance. If our p-value is more than that, it is not significant. If the p-value is less, then it is significant. So we see that our error correction term is less than 0.05, so it is significant. Then what is, so this was C1 is your error correction term. What was your C2? If you go back, you will see that C2 is Y lag 1 and C3 is Y lag 2. So C2 is Y lag 1. Is Y lag 1 significant? No, not significant. Then next, is Y lag 2 significant? C3? No, this is also not significant. Then we can similarly say C4. C4 is nothing but X lag 1. This is also not significant. Now we will take C5. C5 was X lag 2. This is also not significant. So what we see over here, that none of the variables, be it the error correction term or a lag of the dependent variable or the lag of the second lag of the dependent variable, because here we are assuming y to be the dependent. Up till here we are assuming y to be the dependent variable. So none of them are significant except for the error correction term, but that error correction term is also because of other reasons the result is not acceptable. Now what are the remainder? These are the cases where x is the dependent variable, and here also you have this error correction term. This C7 was your error correction term. If you see over here in the previous slide where we have defined all this, C7 is my error correction term up till here, and then you have y minus 1 as 8, C8 and C9 and C10 and C11. So we can see all those over here. C7, the error correction term is significant, but since it is not negative, it is of no use. Then your y lag 1 is also not significant, y lag 2 is not significant, x lag 1 is not significant, x lag 2 is not significant. Had we got here the minus sign for the error correction term, we could have taken the result, but for till now, what the result which is as it is given over here, it shows that there is no long run relationship between the variables x and y. And not only this, after this, if suppose they were these error correction term was significant and we also had some significant explanatory variables or correlates, then what we could have done, we will have to now check for serial correlation, check for heteroscedasticity, and also if you need, you can check for normality. But those things are at the moment not required. The reason being, our model is not valid, and till what we have got, the final result is that there is no co-integrating relationship between x and y. Hope this lecture is clear for you. We will meet again with a new video. Till then, thank you.